Today I'm going to talk about homework 5, question 2 for the lane detection algorithm. So the overall goal for this is to detect the left and the right lanes using the dash cam footage we provided. And then we're also going to be using computer vision for that. And so just a general overview, this pipeline runs, frame by frame. So it's not looking at the whole video, but it's looking at each individual frame of the MP4 file. And then for like a quick list of stages that it's going to go through includes turning each frame into grayscale. So there's no more color. It's only what's bright and what's dark. So that's good for edge detection. We're going to also boost the contrast. So this is good for if the sun is too for sunsets, for example, if it's getting dark, then it's good to see, highlight all the details of that because each video has a different brightness. Then we're going to do a Gaussian blur. I chose an 11 by 11 blur just so that it can smooth out the textures in the video and we don't get additional noise that interferes with the algorithm, so there's no detected false edges. And then I'll also do an adaptive canny. So those thresholds are calculated automatically from the different median brightness for each frame, and that self-adjusts depending on the different lighting. And since there's 5 videos, we need that as well. So let's do an example and run this. I'll put this in the middle. So as you can see, this yellow trapezoid is what we call the ROI, or the region of interest. And so what we basically did is take the whole frame, make it black, and then I chose this specific area, and basically that's the only thing that we care about because it's right above the hood and it's right below the edge of the road. So that's where the lane is actually being detected. Now here it looks a little bit wider than the actual road itself, but I chose this trapezoidal shape because in a dash cam when you're looking at the different perspectives, the closer you are to the road, or closer you are to the camera, the wider it is, and the further you go down the road, the narrower it gets. And so, yeah, so like I said before, there's going to be a black mask, and then everything inside the trapezoid is going to be white, and that's what you'll be able to see. And then when I show a different video later, you'll see why I had to make it that width. Somewhere in my code down here, where is it? Here we go. I talked about how I used these numbers instead. That's what I originally did, and that originally matched the road. So if I were to do this, and and I would do homework 501 video. So now you can see why I made that width. As the car drives down this road, the ROI mask is actually wide enough for this video. And so I just wanted to make sure that it was able to detect all types of roads given the different videos that we were given. So anyways, so after we go through those, let me just run through this again. I'll just have this play in the background. We go through a hue transformation, so that basically takes the edge pixels and converts them into lines through a voting process. And I chose a voting of 25, so lines with 25 or more votes get returned as a rho and theta pair. And then if you lower that threshold, it can catch more faint dash lines. For some reason, it stopped recording, but I'm gonna keep going and I'll play the next video in the queue. So this is a brighter video. This shows a more curved highway. What I was just talking about was the hue transformations. So I was talking about how it takes the edge pixels and converts them into lines through a voting process. And I think what I was going to talk about next was the difference between the left lanes and the right lanes. So here when we shift lanes, we see a different like a transition from the left and the right, and that's because I made a little filter in the middle. So if I play, oops, play this one too. So we go down my code. This is where I did the hue line. So that's just doing rho theta into slope intercept form to get a mxb, mx plus b. But here, yeah, right here is where I set those boundaries. So there's a dead zone in the middle of the road. So say there's cracks, it wouldn't detect those at all. What else did I want to talk about? Oh yeah, I also added a slope filter. If the line is vertical or horizontal, then to also reject that, because um, we're looking at lines that are going to be curved due to the perspective of the dash cam. In order to determine which side is the left and the right, the slope needs to be negative in order for it to be on the left side, while also having an X position left of the center of the frame. On the contrary, the right side, the right line, also needs to be positive slope, and the X position needs to be to the right. So moving along, we create a rolling buffer, and that means each single frame can be a little noisy, especially when the dash lines or the frames don't really detect anything. So I'll keep playing the videos. There we go. So this one. Also, I had to change the system display from 200%, which is the recommended, to 150. And that way we can see the whole video. So as you can see, the right side, it goes away for a little bit and it comes back. And that's because, if the algorithm isn't detecting any lines, it has nothing to show. So creating that little buffer remembers the history of the last 10 frames. So here, it'll disappear again on the right, and then it'll come back. So that just shows like where the lines used to be, and then it'll adjust once it senses lines. So yeah, I tested this over the different 5 videos, and basically what had the biggest impact to make sure it fit was adjusting my mask, because if the mask was too low, then it was detecting reflections off the hood of the car, and that was causing askew lines. Also, like I said before, the width matters as well, because if the road is too wide for the actual mask of the ROI, then it will not detect and it will get garbage. So yeah, I think that's everything. And I might be over the time limit, so thank you for watching, and I will post this to YouTube and submit to Gradescope. Thank you.